Welcome to the deep dive. Today we're unpacking a really fascinating frontier, how AI is being built to create what they're calling a digital neurosurgical assistant. Our mission today, a shortcut really to understanding this absolutely critical foundational step. It's all about teaching AI to see and understand the surgical world through video annotation. Okay, so let's unpack this a bit. This assistant, what exactly is it? What's the big vision here?
Right. So it's essentially an intelligent system. The idea is to provide real-time, context-aware support during surgery.
Like a copilot.
Exactly, like a highly perceptive copilot. Its capabilities could range from enhancing workflow analysis, maybe giving real-time safety alerts, to offering precise anatomical visualization, tracking instruments, and this is key, giving objective surgical skill assessment for training.
Objective assessment, huh? That's interesting.
Yeah, and ultimately the goal is proactive complication prediction, making surgery safer for you, the patient.
Okay, safer. And you mentioned it all hinges on this foundational process, video annotation.
Precisely. Meticulous video annotation. It's the process of enriching that raw surgical video with information tags, labels, basically.
So the machine can make sense of it.
Exactly. It's how machines learn to see and interpret the surgical environment. Think of it like learning to read a map.
Yeah.
You need someone to point out the landmarks first, right? Without the essential training data, these machine learning models, well, they just can't identify the critical elements. The whole digital assistant idea doesn't get off the ground.
Got it. So what specifically are they tagging? What are these key elements in the videos?
So there are really two main pillars here. First, you've got anatomical landmarks.
Okay.
These are specific identifiable structures within the surgical field. They act as reference points for real precision.
Like what, for example?
Okay, so in deep brain stimulation, that's where tiny electrodes are placed deep in the brain for things like Parkinson's. The AI needs to find the subthalamic nucleus. It's a key structure. And it needs to find it with like sub-millimeter accuracy.
Wow, sub-millimeter.
Yeah. Or maybe just identifying an aneurysm itself, which is, the critical target in that type of surgery.
That sounds incredibly precise. Must be challenging in a dynamic environment like surgery.
Oh, absolutely. A huge one is something called brain shift.
Brain shift.
Yeah, the brain actually deforms slightly during surgery. Fluid drainage, tissue manipulation, it moves.
Huh. I never thought about that.
Right. And that makes consistent labeling really, really difficult. The AI models have to be smart enough to adapt, maybe even predict how the tissue will deform. It's a fascinating computational challenge.
And time-consuming for the experts doing the labeling, I imagine.
Immensely. It requires expert neurosurgeons spending a lot of time. It's definitely a labor-intensive part of the process.
Okay, so landmarks is one pillar. What's the second?
The second pillar is critical events. These are moments during the surgery that are crucial for decision-making, or maybe they signal potential complications.
Okay, critical moments.
And get this, some studies suggest around 25% of neurosurgical adverse events might actually be preventable.
25%, that's significant.
It is. So annotating these events could mean tracking blood loss, like down to the milliliter.
Really? Milliliter by milliliter?
Yeah, or identifying something really high risk, like an aneurysm rupture the moment it happens.
Yeah.
Or even just recognizing specific surgical phases, like, say, the 4 distinct phases in removing a pituitary adenoma.
So identifying these events for the AI, any specific hurdles there similar to the landmarks?
Well, yeah, and this brings up a really important point. A major bottleneck right now is the lack of a standardized framework.
Standardized framework, how so?
Well, for defining these events across different studies, different hospitals, what one team calls a step, another might label a subphase or something else entirely.
Ah, so everyone's speaking a slightly different language.
Pretty much, and that makes it hard to pool data to compare results. It definitely hinders progress. That's a big area people are working on.
Makes sense.
And of course, you have the issue of rare complications. If something doesn't happen often, it might not get annotated much just because there isn't enough data. So the AI might remain kind of blind to it.
Right. The AI can only learn what it sees. So given all these challenges, the precision needed, brain shift, standardization, rare events, how do you actually build this annotated video library?
It's a very structured, collaborative effort. You need diverse video sources, first off, from different types of neurosurgery. Think large specialized data sets like PIT-VQA for pituitary surgery or MACS, which is more general.
Okay.
And everything has to follow strict ethical guidelines, patient data anonymization, all of that.
Naturally.
Then the core work relies on expert neurosurgeons doing the actual annotation. As we said, it's labor-intensive, but absolutely essential. You can't skimp on the expertise.
Quality control must be huge.
Paramount. And thankfully, there are some AI-assisted tools coming online now that can help. Things like auto-tracking for instruments or maybe certain structures. They can accelerate the process.
But still needs human oversight.
Oh, absolutely. Human experts still need to verify and correct. It speeds things up, but doesn't replace the surgeon's judgment in the annotation process.
So bringing this all together, what does this meticulous annotation work really mean for you listening out there, for the future of medicine?
Well, it might seem like a technical detail, this annotation stuff, but it's truly the foundational science. It's the invisible scaffolding, if you like, that lets us build these advanced AI tools. It's the bridge enabling AI to eventually provide that real-time decision support, enhance safety, maybe even revolutionize how we train neurosurgeons.
So it's about building that base layer of understanding for the AI.
Exactly. It's about translating the complex visual world of surgery into a language machines can finally comprehend and act upon. It could lead to a future where complex procedures feel safer, maybe recovery's faster for you.
It really paints a picture of the future operating room. Thinking about that, as AI's role grows in high-stakes fields like this, what new ethical considerations should we be thinking about to make sure this powerful tech always serves the best interests of patients and the surgeons using it?